Write on next topic, mechanical properties of solids. Okay, write on the first topic, elasticity and plasticity. Elasticity and plasticity. Plasticity. Not plastic city, madam. Okay. So the difference between elasticity and plasticity is nothing but when we expand the object, when it regains to its original position, we will say elasticity. If expand the object, it doesn't regain plasticity. This is the main important definition of these two subheadings. Okay, write down. If it is regained, it is elasticity. If it is doesn't regain, plasticity. Regain to its original shape. So, the next topic is stress. So, stress is nothing but force by area. Force by area. So, SI unit is Newton per meter square. Newton per meter square. So, force is Newton and area is meter square. So, what is the dimensional formula? For Newton it is ml t power minus 2 divided by L square, which is nothing but ml power minus 1 t power minus 2. This is the dimensional formula for the stress. Next point, there are three categories or three types. Completed? Yes. Once you have completed, let me know. Completed. Okay. Three types. The first one is normal stress or tangential. So, I mean longitudinal stress. Normal or longitudinal. Normal stress or longitudinal stress. Second one is tangential stress. Tangential stress. And third one is volumetric stress. Volumetric stress. Okay. So, only one thing you need to remember. So, tangential stress and the normal stress, no, the name itself says a normal. Normal is nothing but 90 degree. Okay. If an object is there, if I apply the force, okay, on the area, surface area, which is perpendicular, then that is normal or longitudinal stress. Okay. So, for every stress, the same formula only, force by area, but only the terms changes there. So, tangential is nothing but I am applying parallelly. Okay. One is normal perpendicular, one is tangential parallel. Getting the point? And third one is volumetric stress. So, volumetric stress is nothing but that one we are going to deal in terms of fluids. So, fluids is nothing but pressure, force by area. Same formula, no? Yes or no? So, volumetric, like where we talk about volume, a liquid, no? liquid, we will talk about volume, right? The volumetric stress, like it is pressure is nothing but force by area. Okay. So write down the first one. The first one is normal or longitudinal. Normal or longitudinal. The force act perpendicularly. The force acts perpendicularly. The force acts perpendicularly. Okay. So in this, no, like if there is an object, okay, if I try to pull or if I try to push, whatever it is, if I try to pull, what happens here? It will expand. If I try to push this object in both sides, compress. So this is tensile stress, this is compressive stress. Okay. When it is expand, it is tensile. When it is compress, compressive stress we will say. Okay. Take down. Second point and third point. Completed. The next one, the tangential stress. So the other name of tangential stress is shear stress. Shear. Shear or shearing stress. So this stress is parallel to the surface. Third one is volumetric stress. So here pressure is equals to force by area. Pressure is equals to force by area. So what are the stress types we have seen now? For everything the same SI unit. Okay, Newton per meter. Okay. The next one is strain. Strain. First one, normal or longitudinal strain. So whatever stress we are talking, similar to strain we will talk. Okay. So 3 stress and 3 strains. Second one is the types you write first one. First one is a normal or longitudinal, second one is tangential or shaving. and third one is volumetric. Volumetric or bulk. So now write the first point. Strain is nothing but it's the ratio of change in length by original length. Ratio of change in length by original length. So delta x by x or delta L by L. Change in length by original length. So what will be the SI unit of the strain? Dimension less, because this is meter divided by meter, so get cancelled off. So there is no SI unit, there is no dimension. Okay. So write on the first subheading, normal strain or longitudinal strain. Normal strain or longitudinal strain. So the formula is delta x by x. Delta x by x. Formula is delta x by x. Second one is, so normal, no, so it is acting perpendicularly, either compressive or tensile, whatever it is. Okay. Second one is volumetric. I mean volumetric or shear? Tangential or shear. Okay. Right one, tangential or shear. So in this, what we have told, it is acting parallel, no. So parallel in the sense, initially the object will be like this, no. So if I apply a parallel force, this one will be as it is, only the upper part is moving. So can I draw like this? So this is my original length L and this is my change in length, no, delta x. Can I write? This is the only thing changing, no, this is as it is. So what angle it makes? Angle theta. So tan theta is equals to delta x by L, opposite by adjacent. So here like theta is very small. So which means tan theta will become theta. Okay. So whatever the value they are giving, just apply the value, that's it. So theta will be equals to delta x by L. This is the formula. Take down. So the final one is volumetric or bulk. Completed? Not completed. So next one is volumetric stress or bulk strain. I mean volumetric strain or bulk strain. Volumetric strain or bulk strain. So suppose there is a liquid, I am trying to apply the pressure on the liquid. So what happens? It will try to compress, no? Yes or no? So initially the volume will be V, this one will be delta V. Yes or no? So can I say like delta V by V? Change in volume to original volume, and it is compressing, so negative, minus delta V by V, because it is shrinking, no? Okay, the negative symbol indicates that it is shrinking. Completed. Right on the next topic, Hooke's law. Hooke's law. Stress is directly proportional to strain. So Hooke's law states that stress is directly proportional to strain. Stress is directly proportional to strain. Stress directly proportional to strain. So stress by strain is equals to the constant K. So K is nothing but elasticity. Elasticity. So that is modulus of elasticity, we'll say. Okay. So now three types of stress, three types of strain we have talked. Okay. Now similarly three types of elasticity we'll talk, modulus of elasticity. So K is nothing but modulus of elasticity. Now write down the types. The first one is the first type. Young's modulus. Young's modulus. Young's modulus. Second one is rigidity modulus. Second one is rigidity modulus. So Young's modulus denoted by the letter Y. Rigidity modulus denoted by the letter eta. Eta. Eta, not theta. Like this. Neta, eta. Neta. Okay. Third one is bulk modulus. Bulk modulus. Okay. So first one is Young's modulus. So we are talking about modulus, no? Modulus of elasticity, no? So Young's modulus will be equals to force by area by change in length by original length. Stress, like stress and strain. First stress and first strain we have talked, no? Longitudinal stress and longitudinal strain. So force by area by change in length by original length. So what is the SI unit of the Young's modulus? Newton per meter. Same. Okay. Same formula only. This is the formula. Okay. So what is the second one? Rigidity modulus. Eta is equals to F by A. This is tangential force. Listen. So Y will be equals to F tangential by area by delta L by L, and eta will be equals to F parallel by area by okay. So what about the strain we have talked there? Theta is equals to delta x by delta x by L, no? So theta. And the final one, bulk modulus, no? K will be equals to pressure, no? Force by area, P by minus delta V by V. So can I say minus P by delta V by V? I have taken this minus to the numerator, that's it. So this is my bulk modulus. Next one is Poisson's ratio. Poisson's ratio. Poison కాదు, Poisson's ratio. So listen here. See, there is a wire, okay, of length L and radius of the wire is R. If I try to expand this wire, no, what happens? The length will increases. What about the radius? Decreases, no. So this is the thing we are talking in Poisson's ratio, okay, lateral strain and longitudinal strain. So this is my longitudinal, this is my lateral, okay. Write down. It is the ratio of lateral strain by longitudinal strain. Lateral strain by longitudinal strain. So lateral, what's happening here? It is decreasing or increasing? Decreasing, no. So minus R. What about the the longitudinal? So minus delta R by delta L. This is my formula, Poisson's ratio. Minus delta R by delta L. So what is the SI unit of this one? No SI unit, no dimension. Is it? Yes. Okay, write down next one. Relation between Young's modulus, rigidity modulus and bulk modulus. Relation between Young's modulus, rigidity modulus and bulk modulus, that is y, eta and k. Y, eta and k. So first you reverse this, okay, which means y by 9 should be equals to k by 1 plus eta by 3, right? No, cross multiply this one. So if you cross multiply this, 3k plus eta divided by 3, okay, no? Not getting?
Okay, sir.
Take your rough note. Where is the rough note? So 9 by y should be equals to eta plus 3k by k eta. Okay, na? Now you got, now you cross multiply this. So 9k eta by eta plus 3k should be equals to y. Getting? Write down the points. Note point. Note point. Ductile material. Ductile material. DUCTIL. Ductile. Ductile material. So first points. It is the ability of a solid. It is the ability of a solid. It is the ability of a solid to be stretched into a thin wire. It is the ability of a solid to be stretched into a thin wire without breaking. Without breaking. So next one, brittleness. Brittle. BRITTLE. Brittleness. The material will simply snap, SNAP, snap. Snap if you try to pull or stretch it. Okay, they might ask a theory question based on this, like what is brittleness or what is ductile. Okay, the final one, the last point. So potential energy of a wire. So E is equals to capital E is equals to half into stress into strain, 1/2 times stress times strain. Okay, so if you talk here, no, Y is equals to stress by strain, right? No, so we have written the formula 1/2 stress into strain. So if we want in terms of only stress, okay, so I need to remove the strain, no. So if I want to remove, no, so take the strain to the other side, so Young's modulus will come no here. So can I write 1/2 times stress into stress by Young's modulus, which is nothing but stress square by 2y. Okay, if I want in terms of strain, I will take this strain here, so stress will be in terms of strain, no, so strain into y, so strain square by 2 into y. Getting the point? So this is for energy. The work done will be nothing but half into stress into strain into volume. This is work done. So this is energy and this is work done.